Welcome or welcome back to 3 Inquisitive Kids. In this video, we will be talking about experimental probability. Our learning goals for today is to understand the relationship between the stability of data and the number of trials, and analyze the stability of data obtained through repeated trials, and then further develop our logical reasoning and thinking. Combin and Kalie are playing a game of throwing thumbtacks. The nail will either point up or down. Do both outcomes have the same possibility of happening? So Combin says that his intuition tells him that the possibilities are going to be different. Then Kalie says, I agree, but I don't know for sure. So Combin decides to experiment. 2 people played the thumbtack game 20 times and recorded the data in the table below. So here is our table. We have the number of trials, the number of times the nail faced up, the number of times the nail faced down, and then the frequency of both possibilities. Karen played the thumbtack game 400 times and recorded the results in the line chart below. Observe the changes in the frequency of the nail pointing up. Of course, Karen did this experiment for us, so we don't have to do it ourselves. So after 400 times, this was Karen's data. As you can see, the frequency was relatively stable. It didn't really go up or go down. It remained at the same level. So when the frequency swings around a constant value while the number of trials increase, then you would say that the frequency is stable. From the previous experiment, is it as likely for the nail to point up as pointing down? Combin and Kalie played 1,000 rounds of the thumbtack game. 640 times the nail pointed up. They think that the possibility of the nail pointing up is greater than the possibility of the nail pointing down. Are they right or wrong? Well, if after 1,000 rounds and 640 times the nail pointed up, then it means that the possibility of the nail pointing up must be greater because 640 is more than half of 1,000. Here's some practice. A total of 60 red and white identical balls are in an opaque cloth bag. After multiple trials, Combin concluded that the frequency of drawing a red ball is stable at about 25% after many ball touching experiments. So the number of red balls are about blank. We know that the frequency is 25%. So what is 25% of 60? 25% of 60 is 15, so our answer is C. After multiple trials, Combin concluded that the number of times the nail pointed down was 40% of the total number of trials. Which of the following statements is wrong? The frequency of the nail pointing down is 0.4. That is actually right, because 0.4 is equal to 40%. As the number of trials increase, the frequency of the nail pointing down is stable around 0.4. That is also true. The probability of the nail pointing down is about 0.4. That is also true. D. After the first 20 trials, the nail has to point down 8 times. Well, if you do 20 times 40%, the same thing as 2/5, that's the same thing as 8. But our answer is still D. This is so wrong because they say that the nail has to point down 8 times. That one word could change everything. The results of a shooter's shots are as follows. First, I want you to complete the table above. Then, graph a chart of the frequency of hitting the bullseye, and then answer this question. What is the frequency of hitting the bullseye? Here we have our data. So after 10 shots, the bullseye was hit 9 times. After 20 shots, the bullseye was hit 16 times, and so on. So in order to find the frequency of an event happening, you have to do M over N. So the event over the total number of trials. So here, the frequency would be 9 over 10. For the second column, it's 16 over 20. Of course, we have to simplify everything. And so on. And then graph all this data onto it so you can look at the stability of the data. Frequency is M over N. So if event A is represented as M and there is a total of N trials, then M over N would be the frequency of event A. And when the frequency swings around a constant value while the number of trials increase, then we would say that the frequency is stable. So that's all for this video, and I hope you'll come back for our next lesson.